this video, let's discuss few problems. Now remember, we are doing parametric form. So you have to find dy by dx. All right. Look at the first one. So the first one, find dy by dx where x is equal to 2at square, y is equal to at power 4. So x is equal to 2at square, y is equal to at power 4. Remember, I've been telling you t is always the parameter, t is always the variable, not the value of a. Alright. So first what do we do? Do dx divided by dt. This is going to become 4at. By now you should be able to solve it. Dy by dt. This is 4at cube. Isn't it? So we have dx by dt and dy by dt. So we need dy by dx, which is dy by dt into dt by dx. Right? So this is going to be 4at cube divided by, because into 1 by, right? Divided by 4at. Cancels. So what do you get? Therefore, dy by dx is equal to t square. Dy by dx is equal to t square. So the answer for the first one is going to be just t square. I hope this is clear for everyone, right? Now let's do the second one. See the second one? You have x is equal to a cos theta, y is equal to b sin theta, right? So again, now we need to do dx by d theta, not t here, theta. This will be minus a sin theta, and dy by d theta is equal to b cos theta, correct? Derivative of sine is cosine and derivative of cosine is minus sine. Alright, now we need y dash, which is dy by d theta divided by dx by d theta. This is how you reciprocate and cancel off that one, correct? So dy by d theta is b cos theta by minus a sin theta. Nothing gets cancelled. Do not cancel the theta and theta, please. So here the answer is going to be minus b by a cot theta. Clear? Cosine by sine is cot, right? So minus b by a cot theta. Fine. Let's do the third one now. See the third one. X is cos theta minus cos 2 theta, right? And y is equal to sin theta minus sin 2 theta. Again, let's calculate dx by d theta first. Dx by d theta becomes minus sin theta plus 2 sin 2 theta cos 2 theta. That's going to become minus 2 sin 2 theta. So minus into minus becomes plus here. Likewise, dy by d theta becomes cos theta minus 2 cos 2 theta, right? Now the formula is what? Dy by dx is equal to dy by d theta divided by dx by d theta. Correct? Now, if you substitute the values here, the first part is going to be cos theta minus 2 cos 2 theta by minus sin theta plus 2 sin 2 theta. Correct? We need to simplify this. If it's possible, we'll look into it. We need to simplify it. See, when you have 2 cos 2 theta, what you can do, you can write this as 2 cos square theta minus 1. Correct? So 2 times 2 cos square theta minus 1. That is going to become 4 cos square theta because 2 times 2, right? So 4 cos square theta plus cos theta minus 2. Now, what you can do here is, even if you try to simplify, probably you can take cos square, cos theta as common, something like that. All right. So, let's do the math here. Let's do the simplification part first. So, cos theta plus 2 cos 2 theta, right? So, maybe you can do cos theta minus 2 into cos square, 2 cos square theta minus 1 divided by, maybe if you take sin theta common, minus 1 plus 2 cos theta, right? This you have to further simplify. If you look at the expression, I don't think you will be able to, you know, simplify it further, except for the fact that we have 2 cos square theta minus 1 inside the bracket. So you can just keep it as it is, or you can keep it the way how it was before. All right. So this is going to be the answer for the third one. Now let's look at the fourth one. See the fourth one. X is equal to a into theta minus sin theta. Y is equal to a into 1 plus cos theta, right? Differentiate dx by d theta, a into 1 minus cos theta. Y will be a into minus sin theta, correct? Again, dy by dx will be dy by d theta divided by dx by d theta, right? So a into minus a into sin theta by a into 1 minus cos theta. Yeah, so a and a cancels out. See, once this is done, minus sin theta by 1 minus cos theta. Correct? Now, sin theta, you can write this as half angle. So, what you can do? So, you can write 2 sin theta by 2 cos theta by 2 divided by 1 minus cos theta. Correct? Now, when you have 1 minus cos theta, you have to think which formula do we use? If you remember, 1 minus cos 2 theta becomes 2 sin square theta. So, this is going to be 2 sin square theta by 2. 1 sin theta cancels out. So, we end up with minus cot theta divided by 2. Clear? So, minus cot theta by 2. This is going to be the answer for the fourth one. So, this is going to be minus cot theta by 2. Fair enough? Now, let's do the next one. See the next one? See, x value is this, y value is this. Okay, it looks very complicated, isn't it? Sine cube is there, root is there, cos 2 theta. Lot of things are there. Right? Let's take it slowly, because as you take it slowly, things are going to become very, very easier and very, very simpler for you. Right? So you have x is in terms of t, right? So dx by dt, you have the quotient rule, you have the chain rule, and then you have trigonometric function. You have so many things in this, correct? Let's go easy. Let's go step by step by step. All right. So now, first thing, what do we have? Dx by dt, right? Now, this, see, there are multiple methods of solving this one. All right. I will show you one of the methods. Like I told, there are many methods of solving. One method I will show you just to make you understand. That's all. Right? See, sine cube t divided by root of cos 2t, and same thing for cosine. Correct? Now dx by dt, if you try to do it, then you're going to get cos 2t, because the root and square gets cancelled, right? Numerator derivative 3 sine square t into cos t, right? Into root of cos 2t. The first part, that is u dash v minus u sine cube t into 1 by 2 root cos 2t. So this is the first part. 1 by 2 root cos 2t into 2 sine 2t. Alright, this is what we have right now. Likewise, we'll do for y, dy by dt. Again, cos 2t comes here with no fuss whatsoever. Then after that, what we have is, you have to differentiate the numerator. Minus 3 cos square t into sine t into root of cos 2t minus, numerator keep it as it is, cos cube t, then into 1 by 2 root cos 2t into 2 plus sine 2t, right? The 2 and 2 cancels out. Alright, now you got these two big values. Now what do we do is, we'll take LCM within the numerator. In the sense, look at the numerator part, I'm looking at this part. Can you not take sine square t common? You can, right? Sine square t into 3 cos t. If you take the LCM of root of cos 2t, then you'll get this as into cos 2t plus sine t into sine 2t divided by root of cos 2t into cos 2t. Look at the numerator. Okay, if you look at the numerator, 3 cos t cos 2t plus sine t sine 2t. Correct? Now, likewise, we'll do the same thing with the denominator also. Alright? For the next one now, that is, see, dy by dt, if you simplified by taking common and LCM and all, what you can do, so you can take cos square t as common minus 3 sin t into cos 2t plus, here it's gonna be cos t into sin 2t whole divided by root of cos 2t into cos 2t. Correct? Now, if you guys remember, this is dx by dt and this is dy by dt. We need to do dy by dx, isn't it? One divided by the other. So when you divide one by other, one thing is for sure is that the denominator in both the cases will cancel out. Correct? Denominator will cancel out, and the rest of it we need to think of how do we simplify this one. Right? So let's do the simplification now. Dy by dx. So we have cos square t minus 3 sin t cos 2t plus cos t sin 2t divided by sin square t into 3 cos t cos 2t plus sin t into sin 2t. Alright. See, this can be further simplified. Yes, possible. If not, you can keep the answer as it is because we have the 3 and everything, correct? Now, again, I'm telling you, simplification is possible. All right, or you can keep the answer as it is. Fair enough. So, in either of the case, the answer is going to be like this. Fine. Now, let's do the next one now. Ah, see the sixth one. See the sixth one, x is equal to a into cos t plus log of something, correct? Let me directly differentiate this one. See, we have dx by dt is equal to a into minus sine t. Log is 1 by x, right? So 1 by tan t by 2 into secant square t by 2 into half. Okay. Now dy by dt a cos t. Yeah, so you don't have to worry about the dy by dt. Just look into dx by dt part. So in the dx by dt, you have a into minus sine t plus secant square t by 2, correct? Now you can write that as 1 by cos square t by 2. So you can write this as 1 by cos square t by 2 into sine t by 2 cos t by 2 into half, correct? Now 1 cos t by 2 cancels out. So you have a into minus sine t plus 1 by 2 sine t by 2 cos t by 2, isn't it? Now 2 sine t by 2 cos t by 2 is what? Sine t, right? So you have this as a into minus sine t plus 1 by sine t. Take the LCM, you'll get minus sine square t plus 1, which is cos square t. So cos square t divided by sine t. All right. So let me write this one. Dx by dt is going to become a into minus sine square t plus 1 by sine t, correct? Or a into cos square t divided by sine t. This is dx by dt. Now dy by dt is a sine t, right? So you get dy by dx. Dy by dx will be equal to a cos t, that's dy by dt divided by dx by dt. A cos square t into sine t, because the sine t goes to numerator. So a and a cancels, 1 cos t cancels. So sine t by cos t tan t. So the answer for the sixth one is going to become just tan t. Alright. Now let's do the seventh one. See the seventh one? So dx by d theta, correct? Theta is the variable or the parameter. So dx by d theta, so this is going to become a into minus sine theta, correct? Plus sine theta plus theta cos theta. The reason is here you have to apply the product rule, theta into sine theta, right? That's why we get this one. Sine theta cancels. So you get a theta cos theta, right? Then dy by d theta, this will be a into cos theta, correct? Minus cos theta plus theta sin theta. cancel. A theta sin theta. Now again, dy by dx. This will be a theta sin theta by a theta cos theta. Cancel, cancel. Tan theta. The final answer will be just tan theta. See, I want you to, tell some couple of things about, couple of things in this particular question. Not just in this one, even if you compare the last two. This reduced, correct? So this reduced to tan theta. This question also reduced. But the fifth one, I did not reduce. It's not that it cannot be reduced. We can reduce it. When you reduce it, you will get the answer in terms of cot. Cot 3t. So you will get something like that. It's just that I did not reduce, but it's not that it cannot be reduced. So please keep this in mind. Understood? Now let's do the next one. So next one is more like a proving sum. Let's look at the next one. See the eighth one. You have x is equal to root of a power sine inverse of t. Correct? Alright, no problem. Now what we can do, square on both the sides. In the sense, x square is equal to a power sine inverse t, y square is equal to a power cos inverse t, right? Now what you do, you can take log on both the sides, which is going to make things a lot more easier if you want. Or if you want to differentiate like this, you can differentiate like this also. Both of them will give you the same answer at the end point anyway. Okay, it's not going to make much of a difference. Anyway, now let's directly differentiate. We're going to get 2x into dx by dt is equal to a power sine inverse of t, correct? A power sine inverse of t into log of a to 1 by root 1 minus x square. Sorry, in this case, it would be t square, right? This is one first part. So, you need dx by dt. So, dx by dt becomes log of a into a power sine inverse t divided by 2x into root 1 minus t square. So, this is dx by dt. Likewise, we need to do dy by dt, correct? So, differentiate this one, and if you do it, you will get 2y dy by dt a power cos inverse t into log of a minus 1 by root 1 minus t square, correct? So, now what you need, dy by dt is equal to log of a into a power cos inverse t, correct? This divided by with a negative sign 2y to root 1 minus t square. Now we need to do dy by dt divided by dx by dt, isn't it? So dy by dx is equal to dy by dt divided by dx by dt. Correct? Let's solve this one now. Have minus log of a power cos inverse t by 2y into 1 minus t square over log of a power sine inverse t by 2x to root 1 minus t square. So what are the things which cancels out? These two cancels out. Log a cancels. 2 and 2 cancels out. Correct? Right? So the next thing what we need to do, you have minus a power cos inverse t by a power sin inverse t into x divided by y. Correct? The question, what is y square? Y square is nothing but a power cos inverse t. Correct? Isn't it? So, can we write this as minus y square divided by x square into x by y? X cancels. So, what do you get? Dy by dx is equal to minus y by x. Alright? Dy by dx is equal to minus y by x. So, the answer for this question, or we were trying to prove it, isn't it? So, this is the proof, minus y by x. Clear? So, now, whatever problems we have done, this is just few examples. Again, I'll tell you the fifth one, whatever we have done, that can be further simplified. Okay, it's just that I'm leaving that as an exercise for you guys to do it, but that particular question can be simplified. Fair enough? Now here, the rest of the problems, whatever we have done so far, these problems, they all come under the parametric form. Alright? So, in the next one, the next type of function, and not functions mostly, next type of derivative will start from the next video.